I previously mentioned that Arduino is a hardware platform as well as software that helps people make digital devices, but I didn't go into much detail. Before we start playing, I'd like to give you a brief history of how Arduino came to be. This is a microcontroller, which is like a very small, very low-power computer. Most microcontrollers have a CPU, RAM, and long-term storage just like your computer. But where your laptop might have 8 gigabytes of RAM, this thing only has 2 kilobytes of RAM, which is not much memory. That means most microcontrollers are good at running one program at a time and not much else. That being said, most microcontrollers are fairly inexpensive, much cheaper than full computers, as some can be had for a few cents. The other thing that makes microcontrollers unique is their general purpose input-output, or GPIO pins. We can use these pins to control other electronics or circuitry from our program. See if you can find some home appliances near you. You'll probably find some with a digital interface, like this microwave oven. There is a good chance that there is a microcontroller in there that accepts user input, controls the cavity magnetron, the part that generates microwaves to cook your food, and displays the time remaining. Modern cars often contain dozens of microcontrollers working in tandem to control functions like air-to-fuel ratio, the radio interface, and lighting. Take a look around you and pay attention next time you go out. Can you identify some things that probably have microcontrollers in them? When I was first learning how to use microcontrollers, this is often what my projects looked like. In fact, this is a picture of a Simon Says type game I made as part of a group project for school. The mess of wires made it difficult to debug, and sending a program to the microcontroller often involved custom cables that never quite worked right. Just to get a light to blink, you would need to download a multiple gigabyte integrated development environment, or IDE, and spend hours configuring it to compile and upload to your exact microcontroller. Needless to say, this process was an absolute pain. But in 2003, Hernando Barragan, a grad student at the Interaction Design Institute Ivrea, put together a framework for programming microcontrollers known as wiring for his thesis. The software for wiring was based on the processing framework, which was developed in 2001 as an open source, cross-platform development environment for teaching the fundamentals of programming to the electronic arts and digital design communities. As you can see, the IDE for wiring looked very similar to processing. The wiring project also included special firmware and tools to make uploading programs to a select set of microcontrollers much easier than traditional methods. Hernando designed several boards that combined a microcontroller with the necessary supporting circuitry to be easily programmed by wiring. He even worked with several companies to have some of the boards mass-produced. Later in 2003, Massimo Banzi, David Mellis, and David Cuartillas forked the open-source wiring software and renamed it Arduino. The name Arduino comes from a bar in Ivrea, Italy, where some of the project founders would often meet. The Arduino team went on to produce several boards that contained microcontrollers that could easily be programmed by the Arduino IDE, similar to how wiring worked. Arduino board and IDE development continues to this day, and programming a microcontroller is as easy as plugging in a USB cable and writing a few lines of code. Many other companies, including Adafruit Industries and SparkFun Electronics, make and sell boards that are compatible with the Arduino IDE. However, we'll be focusing on the Arduino Uno in this class, as it is considered to be the most popular Arduino starter board and easy to use. By learning how to use Arduino, you'll be able to add electronic control to many projects, like this Arduino-controlled automated watering system. Now that you know a little bit about the history of Arduino, let's start making something.